All right, so this formula, W equals m times g, is the way that we determine the weight of an object if we know the mass, the way we determine the mass if we know the weight. So let's take a look at some examples here. In this first problem, we are asked to find the weight. How much does the suitcase weigh if it has a mass of 20 kilograms? And I know that this is mass because of the units. So in this case, we will use the formula exactly as it is because we're trying to find the weight. It's already by itself in the equation. So we would multiply 20 kilograms times little g. Now, little g is not grams. Little g, up in this formula here, this stands for the gravitational strength. And that is a way of representing how strong gravity is in a certain location. So on Earth, gravitational strength is 10 newtons per kilogram. On the moon, it's a little bit less, and I just noticed I have a mistake up here. Let me fix this real quick. On the moon, it is 1.6 newtons per kilogram. We'll use that in a bit. All right, back to our problem. So the suitcase has a mass of 20 kilograms. The weight is, or the gravitational strength is 10 newtons per kilogram. Notice the kilograms cancels out. And so when we multiply 20 times 10, we get a value of newtons. That is the weight of this suitcase. In the next question, we're talking about a car. We'll assume it's on the Earth. Here we are given the weight. It's in newtons. And we want to find the mass of the car. So basically we're going to use our formula W equals mg. But since we're going to find the mass instead of the weight, the mass is m, that's going to be our variable. That's going to be our unknown amount. So we'll put the 18,000 in over here, and we'll leave the m as a letter. And again, we'll put our 10 in there for little g. That is the strength of gravity on the Earth. So now I need to do a little bit of math. Let me do it the way I see a lot of students do it. So we'll think about the two sides of the equation. We'll divide by 10, divide by 10, and then this side becomes 1,800 kilograms because it's a mass. All right, in this next question, it's about our Chromebook. We're told that our Chromebook weighs 1.4 newtons on the Earth. Okay, so again, this is in newtons. That's our W, that's our weight. So we'll start with our equation. I suggest you write that every single time. We will put in the 1.4 for the W. We are looking for the mass. We're looking for m. And this situation takes place on Earth. So our g value is 10. Again, we would do some algebra here. Divide both sides by 10. And this comes out to be 0.14 kilograms. 1.4 divided by 10 is 0.14. Now it says, if you bring your Chromebook on a trip to the moon, what would it weigh? All right, so the key thing here is we have to know what it is that stays the same when you move to a new location. And the key idea is that the mass will stay the same. So when I take my Chromebook to a new location, it will still have the same amount of matter, the same amount of stuff. So that is the mass. So I'm going to use this number that I just found here, this 0.14, to answer this question. What would it weigh? What would W be? I'm going to use the 0.14 kilograms. And then I'm going to multiply now by the G on the moon, because I'm taking my Chromebook to the moon. So 1.6 newtons per kilogram. This will end up in newtons. The kilograms cancel. So I just multiply my numbers. 0.14 times 1.6 is 0.224 newtons.